So here we go. Still solving systems. We know that systems is going to be more than one equation. We're still solving linear, so they're still going to have to do with lines, but now they're going to be in 3 variables. Okay? So let's see what that looks like. Well, this is what it looks like. Notice we have 2x, and don't be writing this down, of course you won't because it's on your screen, but we've got 2x plus y plus z equals 5, 3x minus 2y plus z equals 16, 4x plus 3y minus, I guess it's a 5. So I have 3 equations in x, y, and z. Solution then, the solution's going to look a little different. I'll tell you why in a minute after we look at it. But these are called, your answer is going to be literally like a 2, 6, 5, x, y, z. It's going to be a three-part answer. And those are called, instead of an ordered pair, when you have 2 of them, it's an ordered pair. When you have 3 of them, it's an ordered triplet. Why do you think they use the word ordered in both of those cases? Why is it an order? Why don't they just call it a triplet or a pair? Okay. And when you plot it on the graph, what is the deal about order? Is 2, 3 in the same place as 3, 2 on the graph? No. So order matters. Okay, Joey? You with me? Order matters. So that's why we call them ordered pairs or ordered triplets. Okay? All right. Now this is what's different. When you have an X, a Y, and a Z, I want you to look at this beautiful trash can collection over here. We're going to pretend and look at the floor line, the baseboards, okay? If this baseboard was my x-axis, that baseboard is my y-axis, my z-axis is the crease coming up in the corner here. So if you can picture a corner when you think of x, y, z, that's what we're talking about. So we're talking 3-dimensional. Well, when you put 3 things together, you don't form a line. What are we forming? We're forming a plane. Do you remember that from your geometry? That any 3 points make a plane? Isn't that one of the definitions? Something like that. It takes 3 points to make a plane. So planes can come together very differently. And because it's 3D, I can't draw it. But maybe these colored, this came out of your book, and so maybe this will kind of help you visualize it. So the blue plane is one of my equations, green plane's another of my equations, and the red one is another equation. So you can see how if they look like this, if they come together like this, my answer could be a point. It could be an ordered pair, ordered triplet, x, y, z. Or if they come together like this second problem, where they come together like this, the answer could actually be a line. So your answer could be literally a line. And that's the intersection of where they all come together on that line. You could also have no solution in a lot of different ways. If they came together like this, there would be no solution. These 2 come together here, these 2 here, these 2 here, but never do all 3 of them come together. So that'd be a no solution. If they're arranged like this, again, these 2 come together here, these 2 here, but never all 3. Or if the 3 planes were all parallel to one another, they wouldn't touch, there'd be no solution. Now the ones we're going to concentrate on, we save this type right here for analysis. So you will not see that type where the answer is a line. I just want to expose your brain to it. We're going to work on these, where you either have a point where they all come together, or you have a no solution. What would be the third? What else do we have in 2x2s? We have one solution, or no solutions, or infinite number of solutions. And what we had 2 equations and we had lines. What were those 2?
It said that was a solution.
Good point. Very good. I was thinking that is one way I would have drawn also, though. What if they're all the same plane? I was thinking, what if they're all, just like we have the collinear, where they're all the same line? What if they were all the same plane? So yeah, this would be 2. Because if your solution is a line, and this line's going to go on forever, there's an infinite number of points on that line, that's true. They could also come together where they're all the same plane, and then it would be infinite number of solutions. But again, we're going to concentrate on coming together in one point, or maybe no solution, but mainly this one right here, because this is new to you. Okay? All right, so let's start with 1. And I would suggest that you watch me and listen carefully the first time. Do not try to write it down the first time, because if you're writing and trying to watch and listen all at the same time, it may be a little difficult. So I'd say watch me do this first one, and then the second one you can write down. Okay? By the way, did everybody have a connection okay?
Yep.
Are you all able to? I figured y'all would have hollered if not. Okay, so I'm going to refer to this one as equation 1, equation 2, equation 3, just so you'll know, so we can communicate about what line we're talking about. The first thing I want to do is look at all the x's, all the y's, all the z's, and see if, because I'm going to use elimination. Okay, that's the form, that's the type I'm going to use on this one. So I'm looking for any x's that'll cancel each other out, any y's that'll cancel, or any z's that'll cancel. So I'm looking here, I've got a 4x, a 2x, and a 6x. None of those will cancel. A positive 2, negative 3, negative y, none of those will naturally cancel. And a 3, 5, and a 4. So none of them naturally cancel. But which would be, in your opinion, and it's certainly an opinion, there's choices all over the place, what would be easy to eliminate if I just put 2 of them together? What would you like to go for? You may have a preference? First 2, okay? If you want to go with these first 2, then Bo, what do you think, and what do you want to get rid of?
X's.
X's. So you think you multiply this one by negative 2? Okay. So let's do that. So I'm going to write down my equation 1. 4x plus 2y plus 3z. Writing down my first equation. Equation 2, as I go through it, I'm going to multiply by negative 2. So I'm going to get a negative 4x. A positive 6y, because it's a negative times a negative, a negative 10z equals negative 2 times negative 14, a positive 28. So nothing new there, that's just like a 2 by 2, because that's exactly what I've done. So these cancel. I'm left with 8y minus 7z equal 29. And please catch me as I make a mistake, because if you have to go back, it's like, ah. Now, here's the key. Now I've got to go back to the original 3 equations and eliminate the same variable again. That's the key. Eliminate the same variable again and pick 2 other equations. So I'm going for the x. I've already put those 2 together. So do we want to put these 2 together or these 2 together? 2 and 3? 2 and 6? Yeah, the 2 and 6. Okay. So this time I'm going to put these 2 together. Let me do this in a different color. I'm going to put these 2 together and multiply this by a negative 3 so that I'll get rid of the x's again. So that's going to give me a negative 6x, a positive 9y, negative 15z. Ooh, what's 3 times 14? 3 times 4 is 12. Carry the 1. 3, 42. Somebody confirm that for me. Is that right? Okay. I multiplied this one by negative 3 because I'm trying to get it to cancel with this 6x. So that was just that multiplied by negative 3. Now I'm going to write down this second one here. I'm just writing it down. I'm not changing anything. Why did I leave this equation like this? Because I still had 2 variables. But I only had 2 variables, and when I get done with this one, I'm only going to have 2 variables. Because I got rid of the x here, to get rid of the x again. That's exactly where I'm going. Let's see, I'm writing this down. Okay. So let's see what happens here. Of course, those cancel. 9y minus y, 8y minus 9z, 40. No. Opposite. All right. Now I have got 2 equations with 2 variables. Now I'm back to what we did last night. Yeah.
How does negative 15 plus 4 equal negative 9?
I don't know. What do you think it is? Negative 11?
Yeah.
Thank you. Negative 11. There you go. Better? Thank you for catching me and being bold and telling me. All right, so I know how to do 2 variables and 2 unknowns. You just did 3 of them for warm-ups. You know how to do that. You've been doing it since Algebra 1. So now I'm going to put these 2 together. And it doesn't matter what I get rid of, but I'm looking at the y's going, wait, what? They're both 8. So I'm going to multiply this one through by negative. It doesn't matter how you do it, but you could get rid of the z's if you want, but I'm just seeing the y's would be a lot easier. So I'm writing down this guy multiplied by negative 1. And then I'm just going to write this one down as it is. Beautiful. 7, 8, 9, 10, 11. That's negative 4z. That's going to be it now. We're going to go back. That's going to be a 2. Is that negative 12?
Yeah.
Okay, so z is going to be 3. Woohoo! I got 1 after the 3. So think about, we've got ordered triplets. That's my z, so that's the third one. The triplets are, well, any ordered pair, ordered triplets, always in alphabetical order. So if we were working with A, B, C's, it'd be an A, then a B, then a C. All right. Now, any thoughts now what I would do now that I have one of them? I have one of the values. Any thoughts how I could get, what do you think, Janelle? Oh, what the, yeah. Oh, good. What? 12 should be a what? Oh, good, good, good. This is a positive, so this is a negative, so this is a negative. Good, because that would have messed me up. Messed me up. And by the way, on these, I will make sure you always get whole numbers. Okay, I'll pick out problems out of the book where you'll get whole numbers so that you'll know if you get a fraction, you've done something wrong. That's just cruel to give you a bunch of fractions at the beginning. So, any thoughts? If I've got a negative 3, yeah, plug it back in where exactly? Yeah, one of these 2 where I have just 2 variables, if I have 2 variables and I put in one of those variables, then I can solve for the second one. So basically, once you do this one time, you're going to start going back upstream. And think about those fish, those trout that go upstream. Dumb, but they do it. So I'm going to put this back in. Doesn't matter which one you go to. Doesn't make any difference, but I'm going to start going back upstream. So I'm going to stick that z, that negative 3 in for z right here. And that's going to give me 8y minus 7 times negative 3 equals 29. 8y plus 21 equals 29. 8y equals 8. It looks like y equals 1. It looks like, y'all. Get confirmation before I move on. That okay? Okay. So now I've got 2 of them. Where do you think I'd go to get the last one? All the way to the top, where I have 3 variables. Plug in 2 of them. So I've got my y and my z. So way up at the top. And no matter which one you pick, I try to find the one with the littlest numbers and the least amount of negatives, which I think would be this first one. So I don't know what x is, but I know that y is 1, and I know that z is negative 3. So 4x plus 2 minus 9 equals 1. 2 minus 9 is negative 7. When we bring it over, it'll be 8. Woohoo! X is 2. X is 2. Now, a few little hints since I've been doing this for this kind of problem for 25, 30 years. What I find is that the kids who try to do this cutting corners, and just kind of holding stuff in their heads or writing things up in here, and you're not organized, you get lost really fast. And it just, and you're like, where the heck am I? And if you come up to my desk and I cannot see order like this, then I'm not going to help you, okay? Because it drives me crazy to look all over your paper and wonder, where the heck and what did you do? It's hard enough to follow when it's in an order, much less when it's chaos, okay? So I need to see some kind of order, and you want to do some kind of order for your own good, even though it's a lot of work, okay? You're only going to have 3 or 4 problems for homework, and you're probably going to get done with it in class. So that's why we only have 11 slides. Yeah, well, actually, let's do another one. Let's do another one, and everybody write down the second one. You did what? Well, don't write this one. I'm going to move on, because everybody else is going to write this one. Okay. So, let's work this one together. Now, let's get this in your notes. So, do some inspection and see, is there a natural cancelization anywhere? Yeah, what do you see, Joey? And we'll call this equation 1, 2, and 3. So which equations do you see will do something cool? Can you talk a little bit louder? Oh, make sure you're on this one. Everybody on this one, is my page different than yours? We're good? Okay. So do you see a natural? I see one that I don't even have to manipulate at all. Search for it, wait for it, Joey. Boom, look right here. These two are set up already to cancel. So Z is going to be my target. As a matter of fact, I'm going to go in and put these two together. I'm not going to rewrite them at all. I'm just going to put those two together. And that's going to give me a 2x, positive 2y. Z's are going to cancel. And 2. Again, the key, I got rid of a Z that time. I got to get rid of a Z again. So we either need to put, 1 and 3 together or 2 and 3 together. Makes no difference to me. Which would y'all like? We just 2 and 1. Right here, we'll go with that. So 2 and 1, and we've got to get rid of the Z's. So we'll have to multiply this one by 5, this one by 6. So that one will be 10x minus 5y plus 30z for negative 20. And 36x plus 24y minus 30z equals negative 42. That goes together. See any mistakes anywhere? All right, now we're going to put those two together. Bleh. Anybody have a preference what I do? I'm going to multiply. Yeah, I'm going to go with the 19 and the 2, even though they're both ugly. So I'm going to turn my y's into 2 times 19 is what, 838? So multiply this one by 19, make it a negative 19, and this one by a 2. Oh, good. Did you see something I did wrong? Because these are some ugly numbers. All right. So coming down, putting them together. Negative 38x minus and 92x trust me, I'll know when I start, put a solution here. So 92 minus 38, 54, that's, those are both negatives, so I'm going to add those together. Divide that by 54 and hold my fingers. Woo, yes, 3. And at that point, if I'd gotten a fraction, I would have known I did something wrong just because I'm telling you. You're just going to get whole numbers. But you could get fractions. It is possible. I'm just not going to do that to you. All right, I got 1. Yes, Justice. Good. You are on it, baby. You got to be a proofreader. So we're going to, yeah, because this is negative because we're adding 2 negatives. We should make this a negative. Yes, beautiful. Thank you. All right, so I got 1. I got a negative 3, and that is my x. So that'll be my first one. All right, going back upstream, let's plug that negative 3 in for x. And that's going to give me 2 times negative 3 plus 2y is 2. Negative 6 plus 2y is 2. 2y is 8. Last but not least, I'll take those 2 back up to the very top. My originals. Let's see, I'm going to take the first one just because right off the bat I see smaller numbers there, but it doesn't matter. So we'll put negative 3 in for my x. It's a 4. Any of these 3, doesn't matter, your choice. Let's see. Fun to do, but we'll do one more. Just to confirm it really good. Matter of fact, this time, I'm just going to work it up here with my mouth shut, and you work. See if you don't end up at the same place. Okay? Actually, I'm going to walk around. You can be better. Knock this one off. Okay. On 5, 6, 9, and 10, I'm going to go ahead and tell you what your answers are so that as you're working through them, you can check them as you go. Because if you get your x wrong, then you've blown it for the rest of the problem, and that's just mean. So I'm going to go ahead and tell you, number 5 is only asking you, it's giving you an ordered triplet and saying, is it part of the solution? How would I check to see if it's part of, if it is the solution? Huh? Yeah, plug in your x, y, and z into all 3 equations. So number 5 is just plugging in and checking. You're not solving. You're plugging them all in. Then number 6, number 9, you start solving from scratch. So number 9, you should get 1, 5, 6. For 10, you will get negative 3, negative 1, negative 1. And number 19, you will get 0, 0, negative 2. 5, 6, 9, and 10. Oh. Okay. So, do not do 6. I know, I'm giving you one. Because this one up here, this 36 is full of fractions, so I'm taking that one off. But I want you to work 3, I want you to work 3 from scratch. So, 5 you're just plugging in and checking. 9, 10, you're working from scratch. 11 you're working from scratch too, but at some point along the way, you'll realize there's no solution. So as you're working it, you'll come up with a situation just like you do with 2x2s, where all the x's cancel out, all the y's cancel out, you're left with some false statement. I just want you to see that, and as soon as you see that as you're working, stop and say no solution. Okay? So let's go with that. Those of you who are feeling confident and have done the others, then, and then 42 and 46, only set them up. Do not solve them. You're just going to set up the 3 equations for the word. Actually, no. We're going to do that tomorrow. We'll do that tomorrow. I'm changing my mind on the spot. We'll do those tomorrow. Let's just concentrate on the mechanics today.